This is the Landscape Ecology and Development lecture. Landscape ecology occurs everywhere. It occurs in cities, it occurs on farms, and it occurs in natural areas. And I think one of the key goals in development is to protect and preserve functioning landscape ecology. So let's look at what we mean by this. Ecology is defined as the study of interactions among organisms. Landscape is the mosaic over which particular local ecosystems and land uses occur. And as you can see in the image here, it might be buildings, roads, sidewalks, streets, um, uh, houses, etc. But these are all overlain over ecosystems. And so it's really the two things together that make up what we call the landscape. Landscape ecology, therefore, is the ecology of landscapes. More on this. So the broad characteristics of landscape ecology systems are defined by three things. They're defined by the structure which is essentially the spatial pattern of arrangement of landscape elements. And we're going to focus on the structure of landscape systems mostly today. It's also got to do with the functioning of the structure, and that's the movement and flows of animals, plants, water, wind, materials, and energy through the structure. And we'll talk more about how this happens. And lastly, change. And this is the dynamics or alteration in spatial pattern and function over time. So I'll ask you, can you think about a way that landscape ecology would change slowly? I'll give you a minute to think about that. Well, some of you who know about landscape succession, that would be one way that landscapes will change slowly. We can think about now about a way that a landscape would change quickly. I see it all the time in the suburbs of the Triangle, where all of a sudden a developer comes in and cuts down all the trees, and that habitat is gone. The function of that landscape is going to be completely different because that developer is going to build houses or shopping centers in that area. So that's kind of a rapid change that in the spatial structure and in the function of the landscape. So I'm just going to walk you through some terms that we use to talk about landscape ecology structure. The first is a real basic term called the patch. And the patch is a relatively homogeneous area that differs from its surroundings. So an example of this might be a grove of trees. You can see in the image on the right, maybe it's a grove of trees right in the middle of a neighborhood. Or it could be a grove of trees right in the middle of a natural field. It might be a thicket of shrubs, or even an opening in a forest could be a patch, a grassy opening in a forest. So essentially patches come in all shapes and sizes. Large patches might be one large patch, or there might be several small patches together that can serve as almost a corridor for wildlife to move through, or there can be an isolated patch in the middle of a highly urban area. And so the shape of the patch and the size of the patch and the location of the patch will all have an impact on what happens there. So a very small patch may only house fungi, insects, or lichen. Perhaps a medium-sized patch can house the fungi, insects, lichen, as well as some herbivores like birds and rabbits and squirrels. And then a large patch, very large patch, think about national park or a state park, may house all of those things, the fungi, insects, and lichen, as well as all the herbivores, and may even house some carnivores like black bear, foxes, or deer. So patch size is directly related the biodiversity of the patch, but there are also other factors that lead to the biodiversity. This is one of the biggest patches I can think of in the middle of a city. This is, of course, Central Park in New York City. And it is actually provides quite a diversity of species in this patch. But the problem with it is that it's not connected by corridors to other patches. So birds can fly in and out. They may find a corridor of street trees to land in as they fly to other patches in the area. But land mammals, um, uh, or even squirrels, foxes, or even insects that don't fly may find a very hard time getting out of this patch and connecting to other patches. So one thing that we need to be clear about is that patches need to connect to other patches in order to host the biodiversity that's ideal. Unfortunately, what's happening with many of our large patches is that they're becoming fragmented. So fragmentation can be characterized by certain different phrases. This is called perforation, where the large patch is perforated by small clearings. This one is called dissections, where you have larger intrusions of change. And you can, imagine that this is sort of like development. This might be scattered suburban development. And then pretty soon you have what might be called dissipation, where development starts to take over and you result, instead of in the large patch, it results in much smaller patches that may or may not be connected. Actually, I should be pointing to this. Smaller patches that may or may not be connected. And then lastly, this is called shrinkage. And this is really where the patches are lost and fragmented. And so this is really what happens as we develop land, both in urban and suburban areas. So we want to make sure that if we are going to fragment land, which we will, because we have development, and development is a fact of life, we want to be sure that we preserve the corridors that allow wildlife to move. So a corridor is a strip of a particular type that differs from the adjacent land on both sides. So imagine a corridor, it might be a river, it might be as simple as a hedgerow or a high transmission power line corridor. They can be narrow or wide, straight or curvy, continuous or disconnected. So you can see that illustrated here. This would be an ideal where you have a patch that's connected to several corridors. When you have an isolated patch like this, the distance to another patch really matters. So in this illustration, we see several small patches that band together to really form a corridor. Very often you can get a bird corridor, but this may not allow too much in the way of terrestrial movement of mammals and insects. So corridors matter in shape and size. Rivers, creeks, waterways, these are very common corridors. And really, if you're going to preserve land, this is the best land to preserve because it allows species access to water, and it's also a linear corridor. It may not be a straight one, but it is a corridor nonetheless. This is showing a transmission line easement, which can also act as a corridor, but it can also slice through patches and start to fragment patches. So how species move through corridors is impacted sometimes by the edges of the corridor or by the edges of the patches. And here you can see a straight edge along a patch means that species will move along the edge, but they don't tend to perforate into the patch as easily as if you have a curvy edge. And this can be a curvy edge, as we look down on it in plan, but it can also be a varied edge in the section of the edge of the patch as well, with different heights from shrubs to understory trees to taller trees. So the shape of the edge has a lot to do with whether species move into and out of these corridors as well. So I got ahead of myself. Here's the edge. Here you see another illustration of the wildlife moving along the edge and fewer wildlife moving into the woodland with a straight edge on it. Here's the curvy edge, and here's even more penetration with the even more varied edge. So edge is critical to patches as well as edges of corridors. The matrix is a background ecosystem or land use type in a mosaic characterized by extensive cover, high connectivity, and/or major control over dynamics. So a matrix might be natural land into which you have some openings or patches inserted. It might be cropland into which you have some patches of trees, or it might be built land into which you have a few large patches embedded in it, and even better, many large patches embedded in it that might be connected by corridors. But the matrix itself will impact the way the dynamics of the landscape ecology work. A mosaic is a pattern of patches, corridors, and matrix, and each is composed of smaller, similar aggregated objects. So one way to understand a mosaic is to think about, say, a squirrel or a fox. Let's look at a fox. They move in larger areas. How would a fox move from this area to this area? Well, you can start to trace some of these, some of the movement from the large patches to some corridors. That's a road corridor. That's not always the safest, but maybe the large patch to the stream corridor, to other corridors that might cross this road and move up into this large patch. That's a mosaic. That's a series of patches, corridors, and the matrix that all allow for habitat movement. So some of the mosaics that we are used to existing in are very, very fragmented. And this series of farm fields only leaves a few little fragments of the creeks and streams, and even just small patches of trees that are left. So this is fragmented to the point that it's really not a very hospitable environment for wildlife. And one might argue that this image of a piece of Boston, while it's highly urban, is less fragmented because you still have some parks that lead from patch to the corridor of the river. So that is what a mosaic is. So it is possible to break down and diagram a matrix into patches and corridors, and look at the connections between them, look at the edges of the patches and the corridors. Here, this is great. You have a large natural patch area. You have some kind of green corridor connecting the large patches. Maybe there are some smaller patches that act like stepping stones between the larger patches. Maybe there's a connection between this large patch and the stream habitat that can lead all the way to the lake. Maybe the same thing happens here, but maybe there is riverside development that breaks that up. So, this is a really pretty clear way to see whether the ecosystems in an area are going to be functional or if they're just isolated patches. Here's another look at some of the terms we've talked about. Remember, the mosaic is the patches and the corridors and the arrangement of those in a landscape. The matrix is the sort of basic base of the landscape, whether it's grassland or farmland or urban land. And then the patches are scattered around and ideally connected by the corridors. So when we start to translate this into development, we can look at better and worse patterns of development. These are very simple diagrams, very large lots and large houses on a lot. But the image on the left is showing a better pattern of development because the houses are closer to the street. What that means is there's less opportunity for use of non-native and invasive plants in the front yard. And so the smaller those areas are, the fewer ornamental and horticulturally inappropriate plants get introduced, as well as, the closer the houses to the street, the more the sense of community in the neighborhood and the more walkability. We'll talk about that later this semester in another module. But the other benefit from moving the houses closer to the street is that the backyards can remain natural. And maybe there's a nature preserve at the edge of this neighborhood, and all of a sudden, a corridor into the nature preserve can be saved and just give that much more health to the habitat. A worse development is just to have these gigantic front yards with big driveways, houses set way back with really no habitat preserved or not much habitat preserved in the backyard. Let's look at a larger scale version of this. This is an approach to development called conservation development. Um, this is a typical way to develop a subdivision where all the land gets subdivided and given to the lots, and people can do whatever they want on their land. What tends to happen is that people cut down trees. They get worried about the trees falling on the house. They want to have more sunlight in their house. They don't want all the pests that come with the trees. I use pests in quotes because I don't consider squirrels or birds or even foxes pests. But in this type of development, one cannot control what people do on their own land. In conservation development, all of this land, everything you see in the light green, which might be an open field, and in the dark green, which is the tree areas, the vegetated areas, all of that land could be given over to a conservation easement. In other words, this land will be preserved forever as conservation land. The lots are smaller, but people live in this beautiful green wooded neighborhood. And so the quality of the neighborhood actually might be better, might be more attractive. And because it's part of a conservation easement, these trees and this habitat is not on the individual homeowner's land, so they don't have to take care of it. This is a win-win for everybody in that it's a win-win for wildlife and preserving the wildlife corridors. It's a win for their property, for the homeowner's property values, and for them not having to take care of and maintain these conservation areas. Usually there is some funding set up with a conservation easement to take care of maintaining these areas. So this is a great way of development. It's called conservation development. On the image on the right is sort of an illustration of the way this works out, where you have more concentrated development here, which leaves a lot more land on the site for conservation. And it can become an amenity with hiking trails, bike trails, kids playing in the woods and all of that, but it becomes part of a conservation easement and isn't maintained by the homeowners. So I want to show you, I want to conclude by showing you an example of landscape ecology and very, very urban development. This is the Gowanus Lowlands project in Brooklyn, New York. This is a master plan that was done by a landscape architecture firm called Scape, and it's SCAPE. Very famous landscape architecture firm doing all kinds of groundbreaking projects all over the US. This is a project that they did where they looked at the Gowanus Canal, which you can see most clearly right here. And this has been a really dirty canal where industry was dumping trash into the canal. People were dumping trash into the canal. The water was very polluted. It was a lot of sediment in the canal, so it was stinky and a lot of soil in the canal. Well, it was dredged, and a master plan for the whole neighborhood was made to allow for stormwater drainage along these habitat corridors into the canal and clear drainage into the bay. Um, and I will give you some images in this next slide of how this is all working. So in addition to the stormwater issues that were solved by this project, a lot of habitat was added just by taking key pieces of habitat in corridors that were connected and connecting these corridors for water and habitat to the bay. This also is becoming a place for people to recreate. It's an amenity for people who live in a highly urban area to be able to get out and get close to nature. Once again, this is the Gowanus Lowlands Project, habitat restoration and stormwater project in Brooklyn, New York. Lastly, I want to show you a couple other, or just one other example of habitat provision in a very urban setting. Think back to the ecosystem services we talked about early on in this module. This is the Buffalo Niagara Medical Campus, also designed by Scape Landscape Architects. This is a book by Kate Orff, who is the founder of Scape, Toward an Urban Ecology, which if you're interested in this, you should look at the book. You can imagine this is pretty intense habitat for a very urban area. And if this habitat along this roadway could continue throughout this whole setting, all of a sudden you can start to see habitat provision in urban areas. And of course, the ecosystem services that come along with habitat provision. Thank you.